Hello everyone, welcome to Sangam tutorials, SP Gubbi online classes for Ncert and Cbse for mathematics and science. So in the last session of mathematics, we proved a very important theorem, that is Sss criteria for similarity of triangles. So before in the last session, before that session, we proved another theorem, that is on similarity criterion for triangles, right? So in today's session we will be going with another criterion for similarity of triangles to prove the similarity of triangles, that is Sss Similarity Criterion. So we will recap all the things once again. So if you want to prove any two triangles to be similar, then you have two options. One is you can prove that they are equiangular, both the triangles are equiangular, hence they become similar. That is according to theorem number 1, that is A criterion. If you want to prove any two triangles to be similar, then you have to prove that one angle of one triangle is equal to the another, that is one angle of the other triangle, and the sides containing those two angles are proportional, then the two triangles become similar. So that is SAS criterion. So today, if you want to prove that two triangles are similar, then we can use another criteria for that, that is called as SSS Similarity Criterion for triangles. So what is this SSS Similarity for Criterion for triangles? Is that here, consider two triangles. You have two triangles. The three sides of first triangle are correspondingly proportional, that is the three sides of one triangle are proportional to the three sides of the other triangle, then both the triangles are said to be similar to each other. So if you want to prove two triangles to be similar, you are having three criteria now. One is AA criterion, which is if two triangles are equiangular, then they are similar. Second criterion, that is SAS criterion. If one angle of one triangle is equal to one angle of the other triangle and the sides including the angles are proportional, then the two triangles are similar. That is the second criterion. And third criterion, today what we are going to prove is, if three sides of one triangle are proportional to the three sides of the other triangle, then both the triangles are similar to each other. So this is the third criterion, right? So it's a logic based. It's very nice, you will really enjoy it. If you want to get a good grip on similar triangles without any hesitation, if sir, give me any problem in the test or examination, I am ready to do it. I am able to do it. I will be ready for doing it. If this is your, these are your words, so 100% these theorems will help you a lot. So unless you learn the theorems very well, you won't be able to solve problems on or numericals or riders or identities on these theorems, right? So let us get into the theorem that is called SSS Similarity Criterion, right? So before entering into SSS Similarity Criterion of triangles, most important, some basic knowledge is required to learn this. That is one lemma. They are called lemmas, as I have done many lemmas before proving any theorems. So today also we have some lemmas. One is congruency, that is SSS congruency of triangles. So if three sides of one triangle are correspondingly equal to the three sides of the other triangle, then both the triangles are congruent to each other. So that is the lemma 1. So lemma 1, right? So I have one triangle, I have another triangle. So let us call it as ABC. Let us call this as PQR. Okay, there are two triangles. So AB is equal to PQ, AC is equal to PR, and BC is equal to QR. So in triangle ABC and triangle PQR, AB is equal to PQ, BC is equal to QR, and AC is equal to PR. So therefore, triangle ABC is congruent to triangle PQR, right? So this is called as SSS postulate, what you have learned in your 8th and next 100 classes. Very important. So if three sides of one triangle are correspondingly equal to the three sides of the other triangle, then both the triangles this is called as SSS postulate. So then comes the converse of BPT. Converse of BPT, once again it's very important, that becomes a lemma 2 here. So you have a triangle. So in this triangle, let us call it as triangle ABC. A line is drawn in such a way that it divides the other two sides proportionately. Then it is parallel to the third side. So if a line divides any two sides of a triangle proportionately, then it is parallel to the third side. So in triangle ABC, if AP by BP is equal to AQ by QC, then PQ is parallel to BC. If AP by AB is equal to AQ by AC, then PQ is parallel to BC. If AB by PB is equal to AQ, okay, AC by QC, then also PQ is parallel to BC. So another one is there. So in triangle ABC, if AP by AB is equal to AQ by AC is equal to PQ by BC, then also PQ is parallel to BC. So this is how we have to remember the Converse of Thales theorem. So if a line is drawn in a triangle in such a way that it divides any two sides of a triangle proportionately, and the proportionality can be like this, and also like this, then the line will be parallel to the third side. So these are the two lemmas which are very much required before proving a theorem, right? So apart from these two lemmas, you have to remember a statement also. So regarding the relation between the congruency and similarity. So that is, if two triangles are congruent, then they will be similar, or two congruent triangles are always similar. Reverse of that may be or may not be true, but this straightaway statement is 100% true. That is, if two congruent triangles are always similar. So if somebody is speaking, I have two triangles which are both congruent. So if they have congruent triangles, then you should say them, yes, you have similar triangles. That is, if two triangles are congruent, then they are similar, right? So with these things, we get into the theorem. You have to remember these two lemmas along with the statement. So let us get into the theorem. Let us get into the statement. Right. If corresponding sides of two triangles, are proportional, if corresponding sides of two triangles are proportional, then they are similar. Right. So this is the statement, very beautiful statement, very logical presentation, right? So now let us read the statement once again. If corresponding sides of two triangles are proportional, so I have to draw two triangles now. So as these two triangles, I am going to prove that later that they are similar. So therefore I should not write both the triangles of the same shape and same size. So they should have the same size but different, same shape but different sizes. Okay, let's get into the diagram. Okay, so I have to draw two triangles now. So let us take one triangle here. Let us take another triangle here. Right. So call it as triangle ABC. Call the vertices. Call these vertices as triangle DEF. Okay. So I have two triangles. So if corresponding sides of two triangles are proportional, that is, we have to identify the corresponding sides. So AB and DE are the corresponding sides, AC and DF are the corresponding sides, BC and EF are the corresponding sides. Now, these corresponding sides are what? They are already proportional. So, the description of the diagram is called data. So, we'll write the data here. So, according to the data, we have to write the name of the triangles. In triangle ABC and triangle DEF, in these two triangles, the ratio between the corresponding sides are equal, that is, the corresponding sides are proportional. So therefore AB by DE, very important, is equal to AC by DF is equal to BC by EF. So in the next coming proof, we are going to use this data at a very important step. So we have to prove that. Alright, so we'll go with this. We have to prove that they are similar, that is, these two triangles are similar. So we have to prove that triangle ABC is similar to triangle DEF. Right. So now let us get into the construction part, because the data is not sufficient. This data is not sufficient to prove this. So therefore, we will go with an extra construction part. Okay, construction. So as like the same construction what we did in the previous two theorems, same construction is going to come. So you are going to copy this triangle ABC inside triangle DEF. So for copying that, what is to be done? You know that. So mark a point P on DE and Q on DF such that DP is equal to AB and DQ is equal to AC, and you have to join PQ. You have to join this PQ, right? So mark a point, right? P on DE and Q on DQ, Q on DF such that, in such a way that, okay, DP is equal to AB and DQ is equal to AC. So apart from this, you have to join PQ, right? So this is the construction part of the theorem, right? So very important. Let us get into the proof. So using the construction and the data given, we are going to prove this, that triangle ABC is similar to triangle DEF. So let us get into the proof. Very important proof. You have to watch it very keenly, because a lot of logical steps are involved in this, right? Now let us take this. So here we have drawn AB is equal to DP, AC is equal to DQ. We have drawn it, but we do not know whether BC is equal to PQ or not. We do not know it because it's not a part of the construction. Just we have joined PQ, that's all. So we have taken a Xerox copy, that is triangle ABC is kept inside triangle DEF in the form of triangle DPQ. Here we have to prove that this and this triangles are congruent, because we have to show that they are one and the same, right? So now let us take the ratios. Here it is given AB by DE is equal to AC by DF. AB by DE is equal to AC by DF. The things are given here. So let us take these two to the proof. So AB by DE is equal to AC by DF. So it's according to the data. Follow the steps. They are very important. Maybe at a certain point you may feel confused. So to avoid that confusion, follow the steps very well. Right. So I have taken the data. I have started the proof taking the data. AB by DE is equal to AC by DF. Now, what is this AB equal to? AB is equal to DP. But AB, or you can write AB in place of AB, I can write DP, that is DP by DE is equal to, in place of AC I can write DQ. So that becomes DQ by DF. So I have to write the reason here. So AB is equal to DP and DAC is equal to DQ. Right. So now we have taken the data AB by DE is equal to AC by DF. I took it here as data. So in place of AB I have written DP and in place of AC I have written DQ. So this entire ratio now gets applied in this triangle. So if you apply this ratio in this triangle, let's see what it comes. So dP by DE, you can see here dP by DE, dP by DE is equal to dQ by dF. In the sense, the line PQ, what we have done with construction, the line PQ is dividing these two sides in the same ratio. That is this ratio, that is dP by DE is equal to dQ by dF. So in triangle DEF, dP by DE is equal to dQ by dF. It has happened now, right? So therefore, according to the converse of BPT, PQ becomes parallel to EF. So PQ is parallel to EF. So this is according to converse of BPT, right? So PQ becomes parallel to EF. For now PQ I can draw PQ parallel to EF. Now, so here if PQ is parallel to EF, no doubt in that this angle, because this line and this line they are parallel to each other, just we have proved that, and this becomes the transversal. So therefore this angle and this angle they become the corresponding angles and they are equal. So if you consider this as parallel lines again, and if you consider this as the transversal, so this angle and this angle they become equal. So that is, they are corresponding angles. So therefore, angle in triangle DPQ and triangle DEF, angle DPQ is equal to angle DEF. Therefore, angle DPQ is equal to angle DEF, and angle DQP is equal to angle DFE. So reason is corresponding angles. The reason is built corresponding angles. So now in triangle DPQ and triangle DEF, two pairs of corresponding angles are equal. So in case of any two triangles, if two pairs of corresponding angles are equal, then the triangles becomes similar based on AA criterion of similarity. So therefore triangle DPQ, is similar to triangle DEF. Take it as equation 1. So reason is AA similarity. AA similarity, right? So triangle DPQ is now similar to triangle DEF, right? Now, as these two triangles, that is triangle DPQ and triangle DEF, have now become similar, then if two triangles are similar, then their corresponding sides should be proportional. So now we will take the proportionality. So DP by DE will be equal to DQ by DF will be equal to PQ by EF. This is possible because both the triangles are similar. This triangle and this triangle are similar. Therefore, their corresponding sides should be proportional. I am taking the proportionality, that's all. So in triangle DPQ I take DP. In triangle DEF I take DE. So therefore DP by DE is equal to DQ by DF is equal to PQ by EF. So I can take the proportionality here. So therefore dP by dE is equal to PQ by EF. Similarity, or by definition of similarity, by the definition definition of similarity we can write dP by dE is equal to PQ by EF, right? So I won't take dQ by dF, I am not taking, just I will take two ratios, that is dP by dE is equal to PQ by EF, just I will take two ratios. So here dQ by dF is not required, that's all. So now here dP according to the construction dP is equal to AB, so I will replace this dP by AB. So AB by dE is equal to PQ by EF. So dP is equal to AB, and that is according to construction. What the construction we have got right now. Here AB by DE is equal to PQ by EF. But what is AB by DE equal to? This AB by DE is already equal to BC by EF. That is according to data. But AB by DE is equal to, it is already equal to BC by EF. BC by EF. That's according to the data. So now AB by DE is equal to PQ by EF, and AB by DE is also equal to BC by EF. That means these two things are equal to the same thing. So that means therefore PQ by EF is equal to, this PQ by EF is equal to BC by EF. So if you cancel EF and EF, you are left over with PQ is equal to BC, which is a very important result. So at the time of construction, I just showed you that PQ and BC are equal or not, do not know it, but just now we have proved that BC is equal to PQ. Now we will take these two triangles now, in triangle ABC and triangle DPQ. In triangle ABC and triangle DPQ we will take. So AB is equal to DP, AB is equal to DP. So AB is equal to DP is according to the data. So it's according to data, and then AC is equal to DQ. AC is equal to DQ. That's also according to that is DQ is equal to AC. That's according to construction. I'm sorry, it's not data. It is construction. So this is also according to construction, right? And also now just we have proved that here PQ is equal to BC. PQ is equal to BC. It is proved. Just now we have proved that. So in these two triangles, that is triangle ABC and triangle DPQ, AB is equal to DP according to construction, AC is equal to DQ according to construction, and BC is equal to PQ. Just now it is proved. So therefore triangle ABC is similar to triangle DPQ. Sorry, congruent to triangle DPQ, because according to SSS postulate, they are congruent. So according to our statement, if two triangles are congruent, then they are also similar. So therefore triangle ABC is similar to triangle DPQ. Take it as equation 2. Now compare equations 1 and 2. Here is triangle DPQ similar to triangle DEF, triangle DPQ similar to triangle DEF, and just now we have proved that triangle ABC is similar to triangle DPQ. That means triangle DPQ is similar to triangle ABC, DPQ is similar to triangle DEF. So therefore triangle ABC and triangle DEF should be similar. So therefore from equations 1 and 2, triangle ABC is similar to triangle DEF. Hence it is QED. Right. So this is the simple proof for SSS similarity criterion. You have to practice this. It's a very important theorem. So you have 4 theorems in your hand now. One is Thales theorem, another is AA criterion, another is SCAS criterion, another is SCAS criterion, Along with that, a very simple theorem, that is the Converse of Thales theorem. So until now, 5 theorems are over. So out of all these 5 theorems, you are going to get one theorem in your examination for sure for 4 marks. So be careful in this. Another theorem you are going to come across in similar triangles, that is based on areas, so which is a little bit different from this type of knowledge. So it entirely based on areas. So let it be. So this is the proof. You have to remember this. You have to practice this. Give different names to this diagram and go on practicing the proof for them. So before writing any step in a theorem, think why it is done. Why I am doing this. What is the reason for doing this? When you think like this in this manner, you will become more logical. Right? I hope you enjoyed the entire theorem. So here, this theorem is maybe it's not in your textbook, it's not for your examination, but still for the sake of your knowledge, I have proved this theorem for you, especially you people. Right? So keep practicing. Sunday you are having a test on that is similar triangles, but all the things until now, what it is done, you have to get ready with these things and face the test. On Sunday, please write a test on similar triangles. So until that, stay home, stay safe.